This section is on the distance and the midpoint formulas, which is review from prior courses. So let's take a look at the top of your notes. We're going to review a little bit of terminology here. You will see a coordinate grid on your guided notes, and it says the grid is called a coordinate plane. You can fill that in. It's called a coordinate plane. And any point x, y, we call that an ordered pair, because of course the order matters. The point 0, 0, we know, is called the origin. And then there's some points for you to plot here. Now mine isn't going to be very accurate on here, but we'll do our best. Let me mark some of these off. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay, we have the point A, which is the point 3, 4, both positive. So we go first in the x direction, 1, 2, 3, and then up 1, 2, 3, 4. So that's point A. We have point B as negative 3, 1. So in the x direction, we go negative 1, 2, 3, and then up 1. So there's point B. We have point C as the point negative 6, 0. So again, we go in the x direction, negative 6, but then the 0 says don't go up or down. So right there on the x-axis is the point C. And finally, we have the point D, which is 0, 5. So the 0 says don't go left or right, but the 5 says go up 1, 2, 3, 4, 5. And that is the point D. So just a quick review of locating points. And again, this is the origin right here, and it corresponds to the point 0, 0. If you'll remember, you can label your quadrants. That's quadrant 1, 2, 3, and quadrant 4. All right, let's look first at the distance formula, and it's written like this: the distance, and then it shows this P1 comma P2. That just means the distance between those 2 points is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. You need to memorize that. That's the difference in the x's squared plus the difference of the y's squared, and then you take the square root of that whole thing. So let's do example 1. It says find the distance between these 2 points, negative 4, 5 and the point 3, 2. So just like with slope, first thing you're going to do is label them x1, y1, x2, y2. So distance would be equal to, write your square root, now we just plug in, x2, 3, minus x1 minus a negative 4, be careful of signs, squared, plus y2, 2 minus 5 squared. So that would give us the square root of, change and change, that makes 7 squared, and a negative 3 squared, which is the square root of 49 plus 9, which is the square root of 58. Now, that is the square root of 58. If we want an approximate, you put that in your calculator, square root, and then 58, and you're going to get approximately 7.62. So that is the approximate answer. But when you have it still in like this with the square root, that's the exact answer. All right, let's look at example 2. It's pretty involved. It says, consider the 3 points. We've got the point A being negative 2, 1. The point B is the point 2, 3. And the point C is the point 3, 1. And it tells us to do several things. First, plot each point and form a triangle. So let's do that first. We're going to plot each of those points and form a triangle. So we've got the point negative 2, 1. So negative 2, 1 right there. Then we have, I'll make that an A. Then we have the point 2, 3. So 1, 2, 1, 2, 3. That's that's B. And then we have the point 3, 1, which is right there. So we're going to draw that triangle like that. And we can't tell just by inspection if that's a right triangle or not. So first we plotted. Next it says find the length of each side of the triangle. Well, the length of the side is the distance between the 2 points. So let's be real organized about this. Let's find the distance of that line segment AB. So that would be equal to, using the distance formula, the square root of, now I'm using A and B here. So let's write those coordinates. That will help us a little bit, A to B. So we've got A is -2, 1, B is 2, 3. So in this case, I have x1, y1, x2, y2. All right, so we're going to go x2 minus x1 squared plus y2 minus y1 squared. So that gives us the square root of 4 squared plus 2 squared, which is the square root of 16 plus 4, which is 20. That breaks down into 2 radical 5. And if you're unsure of that, show 20 with its perfect square factors. Take out that square root of 4, which is 2. So there we have the length of line AB, line segment AB, is 2 radical 5. All right, we're going to do the same thing for line segment BC and for line segment AC. So let's do line segment BC next. Now think what points we're using. I'm going to write them over here. We're using B, which is 2, 3, and C, which is 3, 1. So when I go to label x1, y1, x2, y2, those are different than when we did line segment AB. It just depends on what points you're using. So again, we apply the formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared, which is the square root of 1 squared plus -2 squared, which is the square root of 1 plus 4, which is just the square root of 5. So that's the length of BC. I'm going to fill these in over here. This is radical 5. This is 2 radical 5. Now we need to find this, AC. So to find the length of line segment AC, we're going to use the points -2, 1 and 3, 1. I'm using the points A and C. So x1, y1, x2, y2. Again, we have the square root of x2 minus x1 squared plus y2 minus y1 squared. That gives us the square root of 5 squared plus 0 squared, which is just the square root of 25, which is just 5. And that's the length of AC, so I can write that here. All right, so we did that. We found the length of each side. Now it says, verify that the triangle is a right triangle. Well, think about that. How would you verify that? Well, if it is indeed a right triangle, then, I'm going to say if right triangle, then A squared plus B squared equals C squared. But we don't know what's the A, the B, and the C. So we're just going to have to square each one of those and see if 2 of them add up to the third one. So let's first square the AB, that segment. If I square that, that would be 2 radical 5 squared, which is equal to 4 times 5, which is equal to 20. Let's square BC. That would be square root of 5 squared, which is just 5. And finally, let's square AC, and that would be 5 squared, which is 25. Do 2 of those add up to the third one? Well, yes, 20 plus 5 equals 25. Therefore, we know that, yes, this is a right triangle because side AB squared plus side BC squared equals side AC squared. So that is our proof right there, that it is a right triangle. And finally, it says to find the area. Area of a triangle is given by this formula, 1/2 base times height. Now, you got to figure out what's the base and what's the height. Remember, the base and the height meet at the right angle. So one of those is base, one is height. It doesn't matter which one. So we're going to say A equals 1/2 times 2 radical 5. I'm going to use that as the base, which means radical 5 is my height. A equals, those just cross cancel, radical 5 times radical 5 is just 5. So it's 5 square units as the area. That would be a good test question because it's actually testing and asking you a lot of things to see if you know all in one problem. Keep that in mind. All right, let's look at now the midpoint formula. The midpoint formula is really an average. So if you have a line segment, the middle of that line segment is the average of the x's and then the average of the y's, and it's that point in the middle. So that's how you want to think about it. So midpoint is shown with a capital M, is a point, xy, and it works like this. x1 plus x2 divided by 2, that's the average of the x's, and y1 plus y2 divided by 2, the average of the y's. So let's quickly do a problem using that midpoint formula. Example 3, it says find the midpoint of the line segment where point 1 is the point -5, 5, and the second point, point 2, is the point 3, 1. As always, we're going to label our points, and then what we're going to do is use that formula. So M would equal x1 plus x2 over 2, comma, y1 plus y2 over 2. Those are averages. That equals -2 over 2 and 6 over 2, which happens to be the point -1, 3. Then it says check your answer by using the distance formula. Well, I think that'll be easier to understand if I actually plot these points on here for you. So let's do that. So we've got the point -5, 5. So 1, 2, 3, 4, 5 in the negative direction. 1, 2, 3, 4, 5. So I've got this point. That's point 1. And then point 2 is the point 3, 1. So 1, 2, 3, 1. And it's point 2. And we want to know what is the midpoint, which we found. It was -1, 1, 2, 3, so it's about here. That's M. Now, how could we prove that that really was the midpoint? Well, it would be proven if this distance was equal to that distance. So what we need to find is the distance between point 1 and M. We're going to find that, and then we're going to find the distance between point 2 and M. So let's first do the distance between point 1 and M. So let's think about the 2 points we're using. Point 1 is the point -5, 5, so that's my x1, y1. And M is the point -1, 3, we think, x2, y2. So that distance formula says the square root of x2 minus x1 squared plus y2, which is 3, minus y1 squared. So that gives us the square root of, change and change, 4 squared plus -2 squared, which is the square root of 16 plus 4, which is the square root of 20, which we know simplifies to 2 radical 5. Break down 20 into 4 times 5. So that's the distance right here. It's 2 radical 5. Now we need to show that the other distance is the same. So we want the distance between point 2 and the midpoint. So now what points are we using? We're using point 2, which is the point 3, 1, and that's point 2, and the midpoint, which is the point -1, 3. So x1, y1, x2, y2. So that's the square root of x2 minus x1 squared plus y2 minus y1 squared, which is the distance equals -4 squared plus 2 squared. Oops, I ran out. Equals the square root of 16 plus 4, which equals radical 20, which equals 2 radical 5. So we proved that yes, this is the midpoint because the two distances that it breaks the line into are equal to each other. That was also a good test question.